littéralement tous les objets connectés. Car l'Europe spatiale est une réalité. Et nous en bénéficions tous les jours, sans du reste toujours nous rendre compte. Mais nous ne nous arrêtons pas là. L'Europe est déjà dotée d'un programme espace de plus de 16 milliards d'euros afin de rester une puissance spatiale. En particulier, nous avons accéléré la deuxième génération de Galileo, qui est déjà en cours d'élaboration et qui sera un fleuron de la technologie européenne. Le programme d'observation de la Terre Copernicus, un autre pilier de notre programme spatial européen, fournit quant à lui, jour et nuit, des services et des images de très haute qualité, comme on l'a vu récemment lors des catastrophes naturelles qui nous ont frappés. Nous avons engagé une réflexion approfondie sur sa deuxième génération. Nous travaillons à l'élaboration d'un nouveau projet de connectivité ultra sécurisé par satellite, permettant de fournir Internet à tout le monde en Europe et aussi d'assurer résilience et cryptage quantique des communications. Nous mettrons aussi en œuvre une approche européenne de gestion du trafic aérien, qu'on appelle le STM, et notamment pour assurer une surveillance autonome de l'Europe. L'espace est un secteur absolument vital pour l'économie européenne, et c'est ensemble, avec les entrepreneurs, que nous maintiendrons notre avance technologique. Nous pouvons et nous devons être fiers de ce qui a été accompli jusqu'ici, tous ensemble et à tous les niveaux. J'ai une pensée particulière pour toutes celles et tous ceux qui, au cœur des institutions et des agences européennes, ou au sein de nos partenaires comme l'Agence spatiale européenne, EUSPA, Arianespace, mais aussi les autres membres de l'industrie européenne active dans le domaine spatial, coopèrent au quotidien pour réaliser, construire, bâtir des projets tels que Galileo et en faire une réalité tangible. Merci donc à tous d'œuvrer au succès du programme spatial européen.
Well, the launch vehicle Soyuz will be lifting off in a couple of minutes. We can see it up on the screen. And Joel El-Ghaghi, the DDO, will be announcing the separation or drop-off of the upper composite umbilical connectors any minute now. Now, I'm looking up on the screen, and last night, it was pouring with rain, and now I can't see a spot of rain, maybe a light wind. But there she is. The Soyuz medium launch vehicle is there with the two satellites inside. And as I said, in a couple of seconds, we will be waiting expectantly for the DDO to announce the separation. It's now. Yes, we've just had the confirmation. Well, accompanying me tonight in the studio is Raphaël Chevrier. Good evening, Raphaël, and thank you once again for joining us here in Paris.
Good evening, Emma.
Good evening. Well, you are business developer in charge of innovation topics at Arianespace and our Road to Space expert. Tonight, of course, you will be taking us through each stage of this delicate mission, which unfortunately was delayed twice in a row, but we're back again. And we're now less than 2 minutes away from liftoff. So my first question to you is the launcher now autonomous?
It will be completely autonomous 40 seconds before liftoff when we stop the ventilation of the launch vehicle. And when the Soyuz launcher is tilted from ground energy supply to onboard energy supply. And from that point, we will retract the upper and lower masts. And what you will see 16 seconds before liftoff, and you can see the people actually leaving the Jupiter control room in order to see the show in live.
That must be great to be there.
What they will see 16 seconds before liftoff is the firing of the motor engines.
Attention pour moins 1 minute.
Of the 4 lateral boosters and the main core. And we will go from 0 to full power during these 16 seconds.
So we are currently 1 minute away from takeoff.
Moins 1 minute.
Let's momentarily stop the commentary and sit back and enjoy the liftoff together on Road to Space. But just to remind you all that this is the 13th launch of the year for Arianespace, the 61st mission for the European Space Agency, and the 150th mission launched by Arianespace for European institutions. Stop commenting now.
À tous de DDO, attention pour le début de la séquence d'allumage du lanceur. Blocage du mauvais KM. Allumage triétage à 12 de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Et décollage VL26, Galileo FOC M9. Tous les paramètres à bord sont normaux.
Raphael, that was very impressive. That a ball of fire bolting into
Bonne
the
stabilisation du
sky.
lanceur.
I cannot get tired of it.
I bet.
Like really, it's always very impressive. And this is like, you know, passing through the clouds.
What sort of speed is it going at
It
now?
is night. You cannot, you can hardly imagine that it's night right now because it's so bright.
It's so bright.
The light. So right now, Soyuz is providing the
Console
main
nominal.
thrust for the mission to escape really the gravitational pull of the Earth. And in a few seconds, we should see the separation of the 4 lateral boosters that are surrounding the main core. I mean, you can imagine that in 2 minutes, the Soyuz will have gone from 0 to about 50 kilometers of
That's
altitude.
quite incredible.
From 0 to 2 kilometers per
Bonne
second.
stabilisation du lanceur. Tous les paramètres à bord sont normaux.
Like what
This
is
is
the
probably
DDO
now
saying?
faster than like a bullet, faster than a
Faster
bullet
than
right
a
now.
bullet.
Yeah.
You've got the earpiece. What is the DDO? What did he just say then?
It says that everything is nominal, the trajectory is nominal, so everything's looking good for Soyuz right now. So you can see the light coming from the 4 boosters.
So in 10 seconds, we will have the confirmation, won't we, of the separation of the boosters?
And during this, yeah, oh wow, you can see it.
We can see it. It's
Wow, that's
incredible.
really
What a
incredible.
sight, Raphael.
Because usually you can see it in daylight, but at night it's
At
very
night,
rare.
it's quite incredible.
Yeah.
Must be a
Séparation des blocs BVGD.
So we should be in some seconds as well.
No,
being
so
seen.
it's confirmed. It's separated. You saw it, and you can tell that Soyuz is now waiting only. I'm saying only 100 tons. It was
Bonne stabilisation du lanceur suite à
310 tons
séparation.
before. So it lost 70% of its weight.
Wow, that's quite incredible. But so it's got 4 boosters.
Les paramètres
Is this
propulsifs sont
specific
conformes à
to
l'attendu.
Soyuz? Yeah, we can see now on the 3D images. It has 4 boosters. Can you talk to us about that?
Well, I mean, the size and the number of the boosters that you need for a flight really depends on how much power you want to give to your rocket to place the satellites into space. On Soyuz, you have 4 boosters. On Ariane 5, we have 2, but they are bigger. On Vega, we have 1 booster. So it really depends on the performance that is required for the mission. With Ariane 6, we will have
Les paramètres à bord sont normaux.
2 versions, one with 2 boosters and one with 4 boosters,
Okay.
depending also on the performance of the launch vehicle. To give you an idea, with Ariane 62, you can, with Ariane 64, you can double the mass of the satellites to be put into, for example, geostationary transfer orbit.
So if we look up the images which are coming up now, the 3D images, the wonderful image of the launch vehicle, what can we see? You can see the altitude, distance, speed.
So right now it's 117 kilometers of altitude.
And sorry to interrupt, in 3 seconds we will also be having the separation of the fairing. There we go.
Attitude du lanceur conforme à l'attendu.
That's just been confirmed, has it not?
It is confirmed.
Séparation des 2 demi-coiffes.
So now it's confirmed, and it's a very good
Brilliant.
news because the mission can continue. You can imagine that it's an important step. Otherwise, we could not release the satellites into space. So it means that we are above the atmosphere,
Les paramètres à bord sont normaux.
and that the satellites don't need the protection of the fairing anymore. It was protecting them from the friction of the air.
So if I've understood rightly, we are now waiting for the separation of the second stage. Is that right?
Yes, it's right. And this is a peculiar separation because the third stage is going to ignite 2 seconds before, and this is actually the ignition of the third stage that will push the second stage and separate it from the rest of the launch vehicle. And it should come any
second
now.
now. There we go.
So waiting for the confirmation of the DDO. Because I remind that this is 3D simulations here.
Allumage bloc I, extinction bloc A et séparation.
So it's confirmed.
That's
so
brilliant.
The
That's
mission
really
can
brilliant
continue.
news.
Another important step.
So the second
achieved.
stage, or the main core, has now been separated.
section
The
arrière.
third stage remains, the one that powers the launch. What is the role of each of these stages for the launcher?
Well, having several stages increases the mass of the satellites to be put into
Bonne
orbit.
stabilisation suite à séparation.
So the principle is rather simple, and we progressively get rid of any mass on the launcher that is useless. It's like if you want an image, you can consider a fuel truck. Let's consider that the truck is driving using the gas contained in its tanks. When the first tank is empty, it becomes completely useless, so it becomes dead weight, if you will, and we just remove this dead weight to make the rest of the rocket lighter and to gain power to continue the mission.
So at this stage of the mission, Raphael, how far along is our launcher?
So you can see that it has traveled 780
Fonctionnement normal du lanceur suivant les 3 axes.
kilometers in only 6 minutes.
That's incredible.
So it's now at the speed of 4.5 kilometers per second. I remind that all the parameters are on the screen so everybody can read it. So it's 3 or 4 times
Les
the
paramètres
speed
propulsifs sont conformes à l'attendu.
of a bullet right now.
So we're getting closer to the naval station. What are the specificities? I can't say that word. The specifics of this station.
Well, unlike ground telemetry stations, the naval station is located right in the middle of the Atlantic Ocean. In this case, this is a ship that is equipped with an antenna that we position on the ocean a couple days before the launch.
So this is a mobile station on water, literally.
Yeah, and it raises some logistic issues because we need to position the ship in advance. The ship really needs...
Acquisition de la télémesure par la station navale.
Okay, very good news. The ship needs, I said that it's
We've just
a
acquired
technological issue because the ship needs to be stable and well-oriented in order to receive the signal from the launcher with sufficient accuracy.
Paramètres propulsifs du bloc I,
Can you
correct.
confirm, Raphael? He's confirmed the acquisition
Yeah.
of the naval station. That's brilliant
The
news.
acquisition is confirmed.
So we've already talked about this station for the previous Vega flight, VB20. That flight also had a rather unusual trajectory. Can you perhaps also tell us what direction the launch is going in, our launch is going in tonight?
Well, I mean, this is the targeted orbit that really drives the trajectory of the launcher, and it drives what we call the ground track. It is, in a way, the shadow of the launcher on the Earth's surface. And right now, the inclination of the targeted orbit for Galileo is 57 degrees with respect to the equator. And we have the obligations to continuously monitor the position of the launcher up to a certain altitude. And
Les paramètres à bord sont normaux.
sometimes, like today, it happens that we cannot follow the launcher from a fixed ground station because the launcher passes over the Atlantic Ocean. And it will continue over Normandy and England. This is why we need such a naval station.
It's going over my home country. That's brilliant.
You're English, right?
So yeah, if you hadn't guessed already. So anyway, so we're going in a northeasterly eastern direction. Is that right then?
Yeah, exactly. But you know, we use a different network of telemetry
Séquentiel se
stations
déroule tel que planifié.
depending on the trajectory. For example, for a mission going towards the east, that's the case for geostationary transfer orbit missions, we use a different network of telemetry stations.
Paramètres propulsifs du bloc I conformes à l'attendu.
And when we target the sun-synchronous orbit, we are launching towards the north, and we are using another set of telemetry stations. And the DDO just said that everything is nominal right now.
So can you just tell us at 9:23, 9 minutes 23 seconds, he will be announcing what?
Well,
The
the separation of the third stage, which is another very important step here.
It's now. That's right. We can see it on the 3D images.
Yes,
it's
and we
quite
are
incredible.
waiting. Yes, we are waiting for the confirmation, of course,
And there
from
we
the
have
DDO.
it. I think the most wonderful image I've ever seen of this type of golden mushroom.
Yeah,
What is that?
This is the frégate upper
Extinction
stage.
du bloquis et séparation.
So it's confirmed. The third stage has been separated. And right now, it is the frégate upper stage that is going to continue the mission. It is that upper stage that is going to place the Galileo satellites into their orbits, separated orbit. And from there, the Galileo satellites will place themselves on their operational orbit.
So can you just tell, what is it exactly in a couple of words before we get the announcement from the DDO about the ignition of the first frigate?
Yeah, so the ignition of the first frigate is really to place this upper stage, so it's happening right now, we will need the confirmation from the DDO, to place this upper stage on an elliptical intermediate orbit, and it's going to ignite for 12 or 13 minutes, which is quite long because it requires some energy to place the upper stage on this orbit.
So we're still waiting for confirmation.
Exactly, and then we will have a long ballistic phase of about 3 hours and 20 minutes.
Confirmation du premier allumage de l'étage frégate.
That's confirmed.
Brilliant.
So another,
Everything is
probably
going to plan.
one of the most important
Synchronized
steps for the
sequence.
missions, yes. So I was saying that we will have 13 minutes of ignition of this upper stage. Then we will turn the engines off, and the Soyuz, the frégate, will follow the path. Engines off for a long ballistic phase. It will be like coasting in space for 3 hours and 20 minutes before it reignites. And this time it will change also the trajectory from an elliptic one to a circular one.
A circular, okay.
Yes,
That's
which is going to be the final orbit where the satellites are going to be separated into space.
It's moving at an incredible speed. What can you tell us about this?
Yeah, so right now it's...
You can see the naval station coming into view on our...
Yeah, exactly. And I think that
So
we will go from...
Acquisition de la télémesure par la station de Santa Maria des Açores.
So that's
So
what I was
what is
about to
happening?
say.
Tell us, Raphael.
Yeah, it means that the next telemetry stations just took over the signal. And Santa Maria is...
Where is Santa Maria?
You see that this is an island, part of the Azores archipelagos. It is located west of Portugal. It's in the Atlantic Ocean. And like I said, it is now taking back the signal from the launcher.
So can you remind us again how it's a rather long mission and how long it will last?
It will last 3 hours and 50 minutes in total. So yes, this is an unusual, particularly long mission here. So can you imagine that in 12 minutes we have traveled 3,400 kilometers?
It is quite
we
incredible.
have crossed the Atlantic Ocean in 12 minutes. And right now it's approaching Europe, actually. And it will pass above
Les paramètres propulsifs de l'étage frégate sont nominaux.
So
everything in nominal.
So we're about to lose, or we've lost the naval station. The expert, Raphael, has confirmed the loss of a naval station.
Yeah.
So why are we losing the signal? For how long? And
so this is completely normal. We lose the signal when, from the telemetry station point of view, the launcher disappears behind the horizon. So to answer your questions, we sort of don't need the naval station anymore because it has been recovered by the Santa Maria station. It has taken over the job to follow the launcher. This is why we use actually several successive stations to follow the trajectory of the launch vehicle in real time. And you know, this is like a chain of acquisition and losses along the course with sometimes short visibility holes when a station loses the signal before the next one recovers it.
Well, thank you, Raphael. In a couple of minutes, the two satellites will be orbited into space to join the Galileo constellation, 23,000 kilometers above our heads, which is quite incredible to think of that.
Tous les paramètres à bord sont normaux.
They have, however, already traveled a long way to get here. And we have some footage we'd like to share, which dates from the start of the Galileo satellites and launcher campaign. And it will be coming up on our screen shortly. And Raphael, as usual, I'd like you to comment on them.
Of course, if the image come, because obviously it's a long work before the flight. So here we see that the launcher elements arrive by boat at the Guyana Space Center. So they are stored in large containers, and the Soyuz assembly is done in the integration building called the MIC. So one can notice that the integration is achieved horizontally, exactly what it's done in Russia. And the lateral booster here are first positions around the central core, on top of which the third stage will be attached. And you can see that the operators look
so
very small,
right?
Very yeah, small on the image. So it's quite impressive images that we see here.
It's vast.
And in parallel, the satellites arrived by plane. The two Galileo satellites arrived by plane and were transferred to the preparation building. There, many operations are done in clean rooms. Satellites are removed from their container. They are integrated on their adapter.
They're dust inspected.
Yes, exactly. And like you see, and like you said, these are very, very careful operations. And you will see that after this, the satellites will be transferred to another building where they are carefully mounted. So they are protected here for the transfer. And they are carefully mounted on the frigate upper stage first. Together, they are, so you can see here, with this golden jewel, that you mentioned before.
It's a technological jewel.
They are encapsulated inside the fairing that will protect them from the friction of the atmosphere during the ascent phase. And this assembly structure is what we call the upper composite. And there you see that the Soyuz is transferred to the launch pad horizontally. It is tilted in vertical position. This operation is very also impressive. And we will place the upper composite on top of it. And now it's ready for flight, a beautiful flight that we saw earlier.
Since this operation, what has happened to Soyuz and Galileo? Can you tell us about this Soyuz launcher?
Yeah, we had a lot of operations that happened.
Fonctionnement nominal de l'étage frégate.
That happened for about 9 hours before the flight. Lots of operation. And we saw this magnificent flight happening.
Yes, in 1 minute, the DDO will announce the extinction of the first frigate ignition and the acquisition of Roscosmos. This will be the beginning, obviously, of a very long phase during which will be cut off comments, but you can continue to follow the end of this mission and the separation of the two satellites on Twitter. As I say, we're waiting at 1822, around that time, for the acquisition of Roscosmos, another station. And
Roscosmos, which is located 20 kilometers south of Toulouse. So it really means that the launcher is going to pass in not too long above our head.
Above our heads.
Yes.
That's brilliant to think that. So the flights follow a path of different stations along its trajectory. How many will there be until the end of this
Les
flight?
paramètres à bord sont normaux.
So after Roscosmos, there is going to be another one, new Norska, that will follow the trajectory until the end of the mission.
So we're just seeing up on the screen now, we're about to lose Santa Maria, and we're about to acquire Roscosmos. Can you see there, Raphael?
Acquisition de la télémesure par la
See?
Yeah,
station
we can
Toulouse.
see the trajectory,
It's
the
going
path
to.
very clearly.
You can see that it really is going to pass over your hometown, right?
Well,
No, but the reignition capability of upper stage is very key to perform such complex missions. It's particularly key to launch constellations, for example, because you need to separate the satellites, for example, at different locations in space. And so you need this reignition capability in order to manage these multiple separation satellites into space.
so we've just had the announcement, the loss of Santa Maria. And going back to our two satellites, the two Galileo satellites are the 23rd and 24th satellites to be put into orbit by Arianespace for the European Commission. The previous flight started in 2011, which their own particularities. Raphael, can you tell us about the history of Galileo, which is the largest constellation ever built by the European Space Agency for the European Commission?
Yes. Like you see, the first Soyuz was lifted off from French Guyana in 2011. This was actually the first, this was for Galileo. The first Soyuz flight was for Galileo, and we're celebrating the 20th years anniversary of this launch vehicle. And since then, we performed 7 Soyuz flights orbiting 14 satellites, and 3 Ariane 5 flights orbiting 12 satellites, because with Ariane 5, you can actually accommodate 4 satellites at a time. With Soyuz, we launched 2 satellites at a time.
So how long has Arianespace been serving the institutions?
Well, since the very beginning, since the creation of Arianespace in 1980, it has orbited a total of 180 satellites for European institutions, for the European Commission, of course, for the European Space Agency, and for 11, I think, different countries in Europe. For many applications, Galileo, of course, the Copernicus program, which is the Earth observation program of Europe, for meteorological satellites, for environment monitoring, defense program, and of course, scientific and exploration missions.
So what are the most emblematic missions, Raphael, that Arianespace has launched for Europe, for example?
That's very difficult to choose, of course.
Well, what are your most emblematic ones?
Well, I mean, I remember, I was not working for Arianespace at that time. To reach the comet Kourou 10 years later and deposit like a small Philae robot. It was very,
I'm not surprised you remember that one.
Yeah, it's very emblematic. The BP Colombo space probe that was launched in 2018 to explore the Mercury planet, which is the closest to the Sun. I also can think of a Vega flight who also happened in 2018, the ADM Aeolus, which is an ESA program dedicated to the study of wind profiles in the atmosphere. This is an example of missions dedicated to the environment monitoring.
So what's next on the agenda then?
Well, I'm sure that you know that on December 20, which is in 2 weeks, we will launch the James Webb Space Telescope, which is really going to be absolutely amazing with Ariane 5. It's the biggest telescope ever deployed into space. It will replace the current Hubble telescope. It will be placed, listen to me,
where is it going to be
at
placed?
1.5 million kilometers from the Earth. To study with unprecedented
million kilometers from the Earth.
Yes, exactly. To study with unprecedented detail the deep universe, because you probably know that the more distant you see, you look, the closest you are from the origin of the universe, which is the Big Bang. So it will really witness the birth of the most distant galaxies of our universe. And I'm thinking also of another one who will take off shortly after. It is the JUICE space probe. It will meet the icy moon of Jupiter, which has really fascinating worlds where scientists expect to find some forms of life. It is going to be very, very exciting.
Well, Raphael, we're just about to have soon the first phase of the frigate ignition extinction. The DDO will announce that to us soon. Look, coming up on our screens. So the 2 satellites on board the Soyuz launcher tonight are Galileo FOC M9, Sat 27, 28 we call them, and they're the 27th and 28th in the constellation. So, Raphael, where are they now?
So we are waiting for the confirmation of the cutoff of
but
the
where
frigate
are they now?
engines.
If you look at the map up on the screen, they're floating.
Can you see?
Coasting.
Can you recognize?
Can I recognize? Is it England?
So right now, just to tell you that right now it's 600 kilometers of altitude, which is quite high.
I don't know where it is, but you're going to tell me. So we're still, as I say, waiting again for the announcement of the DDO, the confirmation from the DDO of the frigate extinction.
Yes, exactly.
Confirmation de l'extinction du frégate.
Raphael?
Another very important step, because we have the confirmation of the extension of the frigate engines. So right now, it's a rather long journey that is waiting for the frigate. Is going to stay there for 3 hours and 20 minutes. We will have a short telemetry loss for about 21 minutes, but like I explained to you, this is completely normal. And then we will have a second boost of frigate in order to circularize the orbits.
Can I just tell our listeners that, just to remind you all, we will be cutting off all comments during this long phase of the mission, but just don't forget that you can follow us the end of the launch on Twitter. That's what I wanted to say, Raphael. Everyone can follow us on Twitter. So what are the next steps of the mission, and what are the most important ones?
Yeah, this is what I was explaining. The second boost of frigate is going to circularize the trajectory, and it's going to be at 23,000 kilometers from the Earth. And shortly after this, the satellites are going to be separated radially, and they will reach their own operational orbits using their own propulsion means. And from there, it's going to be the end of Arianespace mission, of the Soyuz mission, but this is going to be the beginning of the life of the satellites. Let's hope for many years to come in order to deliver all the applications that we've heard earlier to the citizens.
Well, we are about to lose the visibility of Assoguel, and I would like to just thank you, Raphael Chevrier, for being with us tonight at this late hour, now early morning here in Paris, and helping us to decipher. There we go, the DDO has just confirmed the loss of visibility of Assoguel. As I say, not always easy the different stages of today's VS26 mission to explain, but you've explained them to us wonderfully, and I must thank all the teams here who have helped us prepare this program in Paris. Say see you soon, everybody, on Road to Space for the next fabulous adventure, and don't forget to follow us on Twitter for the rest of the mission. And I must say goodbye to this wonderful golden mushroom, which is floating, coasting in the airs tonight into space.
Thank you, Emma.
Thank you, Raphael.